In this video, we're going to be doing some polar coordinate practice. You can follow along with this video, and it is non-calculator active, so you should be able to do these computations with unit circle knowledge and basic arithmetic. So, number 1, the location of a point in the plane is given by polar coordinates 3, -3 pi over 4. Write two different representations, one with a positive r and one with a negative r, for this point in polar coordinates. So, in general, if you have a polar coordinate, it is equivalent as long as you add 2 pi to it. Or if you have the form negative r and the angle plus pi. One coordinate point, you can have r of theta. So you have a positive radius and a positive angle. You can also have a variation where you have r and a negative angle, a negative r and a positive angle, and a negative r and a negative angle. Here, let's find a positive r. So we're going to write this 3 pi over 4. We want to make this have a positive value, so we're going to take negative pi over 4, add 2 pi. That's going to be 8 pi over 4, and this is going to be 5 pi over 4. So this is going to be the point 3, 5 pi over 4. All we did was add 2 pi, which shifts it to the next cycle. Now for our negative r, we can use the rule that we highlighted here, where you have a negative r and then you just add a pi to it. So this is going to be -3 pi over 4 plus pi. Now, pi over pi, it can be represented as 4 pi over 4, and that's equal to pi over 4. So that's going to give us the point -3 pi over 4. Given the rectangular coordinates -3 root 2, 3 root 2, convert to polar coordinates on the interval -2 pi is less than or equal to theta is less than or equal to 0. So when you're converting from rectangular to polar, that's xy into r theta. So these are xy values, and the relationship that we can establish is r. So we have to find r, and that's going to be the root of x squared plus y squared. So we just plug in our 3 root 2, and we square those, and we get 6. Now we have to find theta. So tangent of theta relates y and x, and that's going to be 3 root 2 over -3 root 2. That's going to equal to -1. Now we have to ask ourselves, tan theta equals to -1. How can we get that? We can also write these points to figure out which quadrant this is going to be in. So when you have a negative x but a positive y, that's going to land you in Q2. So that's -3 root 2. And you have a 3 root 2. It's going to land you somewhere over there with your x, your y, and then this is going to be your r. So we can decipher that our theta can be found by taking the inverse tan of both sides. And note that inverse tan has a range from this half of the unit circle. So that is from 0 to pi over 2, and also from 3 pi over 2 to 2 pi. So it has to return a value inside of here only. So whenever you have an angle in Q2, what you do is your angle is going to be pi minus pi over 4. And that is going to be 3 pi over 4. So now we have our radius and we have our theta, so we can write our point finally as 6 3 pi over 4. What are the rectangular coordinates xy that give the location of the point with polar coordinates r theta is equal to -5, -4 pi over 3? So this is a polar. So what we have to do is we have to convert this into rectangular. That is xy, illustrated here. So x is our cosine theta, y is our sine of theta. Our radius here is -5, and our theta is -4 pi over 3. So, but we have a negative angle, and we want to make it into a positive angle because it's easier to work with. So to do that, we can subtract it from 2 pi and then find the corresponding angle that is there, that is positive instead. And you might think that doesn't work, but it does work because the angle is going to meet at the same location. So let's say you have an angle that is pi over 4, and then you have an angle that is measured from the positive x-axis but goes clockwise, and then normally we go counterclockwise when we're measuring angles. And this angle is going to not be pi over 4, it is going to be 2 pi minus pi over 4 in this example, and that is a pi over 4 minus pi over 4, which is 7 pi over 4, backwards, even though 7 pi over 4 is normally over here, but this is measuring backwards. But going both directions, it leads to the same point. It's just a matter of how did you travel around the circle to get to that point. So we can write 2 pi as 6 pi over 3 minus 4 pi over 3. That is 2 pi over 3. So what you can do is there's also a second way you could tackle this cosine and sine with if you wanted to use the negative angles, which I'll show you how to do now. So cosine -4 pi over 3 has the property of being equal to cosine 4 pi over 3. That's because cosine is even. And 4 pi over 3 on the unit circle, that is 4 times 60, which is 240, which is going to be here. That is going to be -1/2. Now, sine -4 pi over 3 is the same thing as negative sine 4 pi over 3. This is going to be negative √3 over 2. It's still our 4 pi over 3, but we're looking at our y, so that is, because it's in Q3, Now, after this, you have to multiply it by r, though. So, here, the same thing. These are also going to be equal to -5, and this is going to be and here 2 pi over 3, that's root 3 over 2. This is 5 over 2, and this is -5 root 3 over 2. Just to draw it out, 2 pi over 3, right there, that is over 3, so that's going to be 60 degrees. That's 1/2 and root 3 over 2, but that's going to be -1. So that was -1 and positive root 3 over 2. Put that over. Just to have that close. Now, do we box our answer? Yes, did. So that's 5 over 2, -5 root 3 over 2. For each set of 4 polar coordinates which does not belong. So what we can do is first we want to simplify angles. So we have, for example, in our first blocks, 19 pi over 6. So 19 pi over 6, we can subtract 2 pi by going to the next, because we want to get it inside of 0 to 2 pi. That way it's easier to manage, and you know those values on the unit circle easier. So that's 12 pi over 6, 7 pi over 6. So that's the same thing as 4 7 pi over 6. And we can also convert our negative forms. So what we want to do is know so -4, we can rewrite this plus pi. That's going to be 4 pi over 6. So we can compare 4 7 pi over 6 and 4 pi over 6. They both have a 4, but the angle is different. So we can see that they're in opposite directions. So that means that the one that doesn't match the others is going to be this one. Now, a complex number is represented by a point in the complex plane. The number has rectangular coordinates -√2 to √2. Which of the following is one way to express the complex number using its polar coordinates r, theta? First, we can find r. then you can find theta. You have a negative x and you have a positive y. So it's going to be in this quadrant 3, 2. So that means that your theta is going to be pi minus so then your final polar form is going to be r and this is our answer based off what we were given. A point P in the complex plane has an r value of 5 and lies on the terminal side of an angle. Theta is equal to negative 7 pi over 6. Write this point in its rectangular form. So instead of using negative 7 pi over 6, you can use 5 pi over 6. But in case you want to use so I'm going to do it with both. These are even. We know 7 pi over 6 is 7 times 30 degrees, which is 210 degrees. And its theta is going to be reference of 60 is 30, so that means you have, but it's in Q3, so it's negative. Now sine. Now you multiply by 5. Same for 5 pi over 6. 5 pi over 6, you have 5 times 30. And that's going to be of 60 degree of 180 divided by 6, which is 30 degrees. So what you have is your x is going to be negative and here you have 1/2. So you have negative 5 root 3 over 2 plus 5 over 2 pi. Now, the complex number r plus cosine theta plus r sine theta can be expressed in the form a plus bi. If r is going to be negative and 3 pi over 2 is less than or equal to theta is less than 2 pi, which of the following is true? So what we know is we have to examine what our axes are. So our vertical axis of the complex plane is imaginary, and our horizontal is going to be real. So what we have is a negative r, and it has to be on this range. We need to know where this point lies, and we also need to know what the sign of A and B are. So what this interval means is we're in Q4. So in Q4, you have a positive x and you have a negative sine theta, negative y. So because we know that r has to be negative, that means we multiply positive and negative trig values by a negative r. So because we have that, we have x is going to be negative and y is going to be positive. So that means the point is in Q2. That means that it's above the x-axis and it's to the left of the imaginary axis. That's in this form where it equals z because it's being multiplied by I. So it's A. The graph of the polar function r is equal to f of theta is shown for theta is in between 0 and 2 pi and can be equal to either of them. So what we know from the graph, it has y-axis symmetry. It also bulges up and has a max at theta is equal to pi over 2. Now if we test the sine versus cosine, we know sine is going to be symmetric about y, so this has to be a sine graph. And we know that cosine is symmetric about x axis, so it's not that. From the graph, we can see that our max radius is 6, and 6 is going to be a plus b. We can see they're all 2 and 4 here, so when you're looking at a and b, you don't look at this middle sign. That's not important. But what is important is that sign, because it tells you which part of the graph it lies on. If you have a positive sine theta, it's going to be up. Most of the graph is going to be up. If you have a negative sine theta, most of the graph is going to be down. You can also write some of this information for cosine, even though this is not a cosine graph. So cosine theta, just to make a comparison. Well, if you have a positive cosine theta, it's going to be to the right majority. If you have a negative cosine theta, it's going to be to the left. This is going to be B. because we can also see that b minus a, which is 4 minus 2 is equal to 2. That's going to be the minimum radius, and this is the max radius. We can also see that the amplitude is 2, and our midline is, our amplitude is 4, and our midline is 2. The graph of the polar functions r is equal to f of theta is shown for 0 is less than or equal to theta is less than or equal to 2 pi. Which of the following is the equation for f of theta? So for petals, if you have an even number of petals, that means the number that's representing this number of petals is going to be even. Because if you have n and n is equal to an even number, that means your true number is going to be n times 2. Therefore, we can see all of these have a radius of 4, and we can also see that all of these have an even. But now the question is, which one is it? Now, what we see is that it cannot be 2 of theta because, it cannot be 4 of theta because that would be the real, and it's not the real, it's actually double. And we can also see that we have to look at when it is sine versus cosine. So when it is cosine, it means that a petal has to be on the x-axis. If it's sine, that means there has to be a petal on pi is equal to pi over 2, or the y-axis. So we can see that we have petals that lie on the vertical and also the horizontal, but they lie on the axes. Sine, it lies on the diagonals. Therefore, we can see that C is our answer since it's on the axes. The polar function r is equal to f of theta, where f of theta is equal to 1 plus 4 sine theta, is graphed in the polar coordinate system. Complete the following statement about the distance between the origin and the point on the graph with the polar coordinates f of theta on the interval pi over 2 is less than or equal to theta is less than or equal to pi. So, from pi over 2 to pi, we know that sine decreases and sine stays positive. If this is our sine graph, we can label this. So we're highlighting, no, not this, pi over 2 to pi. Sine is decreasing. You can see that because if you draw these tangent lines, we can see they're slowly getting steeper, but they're getting more negative. So that means that the distance from the origin, okay, we can see that it's positive and decreasing, but we can say that the distance from the origin, this is defined as the absolute value of r. And since we know that r is increasing, or r is positive and increasing, the distance is going to be decreasing, because if it's positive and it's also positive and decreasing. That means the distance is decreasing because right now it's positive of a radius, but it's getting closer and closer to the pole, which is 0, 0. That means that it's getting to a smaller distance. This is because f of theta is positive and decreasing. The polar function r is equal to f of theta, where f of theta is equal to -1, -3 cosine theta is graphed in the polar coordinate system. Complete the following statement about the distance between the origin and the point on the graph with polar coordinates f of theta, theta on the interval 3 pi over 2 is less than or equal to 0 is less than or equal to 2 pi. Now cosine in Q, we know it's going to be in Q4. And we know that cosine in Q4 increases and is also going to be positive because Q4 is 3 pi over 2 to 2 pi. If you graph that, cosine starts here, so what you have is this interval. We can see that if we draw tangent lines, we can see that it's increasing here. And it's also positive because it's above the x-axis. Actually, no. What am I saying? That's decreasing. That's because you have -3 cosine theta. Because it's -3 cosine theta, this is negative and becoming more negative. So that means that in total, this function is going to be a distance of the absolute value of r. So right now r, we know, is negative and decreasing, getting more negative. That means that r is going to be increasing. That's because if it's negative right now and it's only getting more negative, that means it's not getting closer to the threshold of the pole. It's not approaching the pole. It's going away from the pole. So because of that, the distance from the pole is increasing because f of theta is negative and decreasing. The polar function r is equal to f of theta, where f of theta is negative cosine theta. It's graphed in the polar coordinate system for the interval 0 is less than or equal to theta, less than or equal to 2 pi. Complete the statement about the maximum distance between the point with the coordinates f of theta and the origin. So the max distance from the origin. the absolute value of r is going to be cosine theta absolute value. The maximum distance of cosine theta, we know, is equal to 1. That's the range. So this occurs when cosine theta is equal to plus or minus 1. That happens at 0, pi, and 2 pi. So we can see that it's 1 here, here, and then here, flip-flopping. Or you could say that it occurs at 2 pi k, where k is a part of integers.